Should be good here. You guys good on your side? Yes, sir. Cool.
Cells have been running.
If you can get away with
Hang out. Is that?
how long does that battery go? Is it possible to keep the stream going?
I wouldn't prefer that. Would be possible. That was like 70% right there. That was like 5 minutes. I'd like to swap out. If possible. Does that cause a headache for you?
Not right now. Well, I mean, so we have that demo, then what else?
Spam. I'll keep it going. You'll just see me walking between. It's fine.
Okay.
I'll keep it going.
As long as the battery goes, yeah.
Okay.
And if you need to do another one,
How'd you get it to stick again? Alright, they're coming our way.
Can you open the garage door first?
The lid is on? No.
I know that, but can you open it right now so we can go in and show the machine? Then they will do a demo and then they go back, come back on.
Alright, sure.
Yep, it's ready to go.
so they can put their own stuff. A lot of new equipment.
Hey, what's up?
Hey, how's it going?
Good.
Through the window and then all right. So Josh Gert is going to give an overview of this, and you guys can go in and kind of look through the cell.
Right, so this is our microsand dual robot AFP system. The robot we have here in the middle of the room is the one which deposits the material. The head that's on there right now is actually a single lane ATL head set up for doing a single 1-inch wide strip of material. It's set up for thermoplastics with a laser line heating system. So this is kind of a counterpoint to the variable spot size laser we had over there, which is integrated into the head. This laser is actually powered through this umbilical. That's fiber optic and water cooling. The reason we are using the wider material format here is to benefit this toolless ATL process, where we actually to start out building this thing. It's in this part, what we've done is we've overlapped every toe 2/3 of the width. So essentially the first ply is 3 plies thick, and that allows us to build up a little bit of stability so that we can get this first ply down before we start adding additional layers of material. After we build that first ply, we can switch to the 1/4" AMP system so that we can do more refined material placement for localized reinforcements and increased steering. The robot you see on the left-hand side is the support roller. Once the initial plies are down, it's actually just a passive roller that is supporting the profile of the part in space, the action force that's being provided pneumatically by the deposition head. But while you're doing the first ply, the material coming out of the ATL head is actually not actively fed out of the head. So the support roller is servo-driven, and it actually pulls the material out of the head as you're laying down the toolless first ply. If you don't have that, what basically happens is you only pull out enough material to create a straight line from your start point to your end point. You end up just making a flat panel. Essentially, we can build any moderately contoured shape that fits inside this large window frame here. Like Ruda mentioned earlier, what we're doing right now is this is the profile of the Frankenstein demonstrator aircraft wing skin. We're actually using this process to build a face sheet for later building thorough set parts on. So we're using this as a way to demonstrate rapid tooling prototyping. We're going to be creating this face sheet on here and then mounting it onto a cheap steel anchorage structure to provide rigidity and then do final profiling off the line. We're building up our competency and our part quality that we're going to generate using the toolless process so that we can actually make structural parts directly off of the machine. You see here on the bottom left, this is actually a small scale part we're working on of the same profile as this wing skin. This one is at the full targeted thickness. This is actually a 24-ply laminate, and then we added additional stiffening structures on the back. And this is all in situ consolidated neuroplastic. This is Solvay ABC with AS4D fibers. Any initial questions on the toolless process before we demonstrate some layup here? Okay, well let's step out of the room and then Gage will fire up the machine and we'll see some layups happen. Also equipped with a closed loop heating control on the laser system so that we can maintain the targeted nip point temperature, which allows us to create a higher quality in situ laminate.
live streaming it to the screen up there.
Robot 1 because I mean, it's the master. Yeah, I'm not on other angles. I would do other angles, but the clamps will hit the clamps. We are able to do a complete like lid, but because this lid is sat up there for 2 weeks, it's like ready to fall off. And yeah, I talked to Josh about this. Like we could do a new lid, but then all they're gonna be able to see is plywood build up, and there won't be a whole part there. But he decided to just run over it like this. I mean, I could go run a 45. If somebody wants to see it as well. That would be a little bit of a mess. Base pod, line 1, line 2, force base, and then line 3, 45s. But I have to be very careful. I don't know where the robots so maybe 30. I don't know how many courses are now. I do 60, and I run 45 in the middle, and I think I do a little smaller, maybe 40. I want to stay away from the clamps. Make sure that the robot can do 45. Okay. It's way too hot.
Pretty basic.
Sorry, guys. We're starting to get busy. Hey, I'll be here all week. No.
Oh, you should be good. Yeah. Okay. Cool. All right, good. What's up? Yeah, it's just starting opening it.
Yeah, don't put the camera on. Yeah. you guys can come in.
Get this thrown out of the way.
This is our electronic scram cell, scram plus plus. So this is kind of a factory cell, combine a bunch of different capabilities. We have some example parts we're showing you right now. This part here is a combination of three different processes. So this is a rapid prototyping technology. What I'm showing here is we used a pellet fan extruder to print the large volume of this tool, and then we've swapped out that manufacturer for a spindle head machine with final profile of this is the Frankenstein lead top at 100 scale to demonstrate some of the type contours that the machine is capable of. And then if you come around this side over here, you'll actually see AFP layout directly on this tool surface. So this is again another in-situ consolidated normal plastic AFP process like we've received on the tools there. Here we're creating our own tool for the machine. With complex geometry like this, the process would be to finish the part on this tool, and this would go to the solve pad, and would actually dissolve the tool away from this
shake off before you eventually activate? See, I didn't even realize you had to have those on all the time.
I do.
So, as soon as they shut the door, it'll pop up. I'm going to be through that window. I don't know if I can see you through there, but just do your thing. I have about 20 minutes, so if it's 10 minutes, that's fine. And I'll wait to get your clearance before I drop down. Or I'll just wait until you open the doors.
No worries at all. The other thing we can do is we land on this pantry if you wanted to.
I'm not going to trust myself. Just, I got a little bit bigger landing strip. But I'll wait for you to be finished up before I bring it down. You like this thing?
What's it?
You like this cell?
Oh, fuck yeah.
It's pretty cool.
There's nothing to not like.
It's awesome, man. I've never seen the metal printing, and I've actually never seen the AFP in action, so this will be a first for me. I might cram your space here. I gotta keep an eye on that drone. So. 6%.
Okay, this TV here is the operator camera. You have In this bottom left view, you're looking at where the material will be leaving the head as we're printing. Then we have a side profile where the material comes out from the side. What you see here is actually the periscope where the laser is guided down to the roller. And I would like you to pay special attention right here so you can see just how tight that contour is for this AFP head. So that's, we don't have any other system that can do continuous fiber in that sharp of a contour. Yeah, this is also in situ consolidated thermoplastics. So I believe it's the exact same laser diode as what's on those heads. Slightly different optic because we can change the material width of what we're AFPing. So we have 1/4" toe right now, but we can swap out for 1/8 or half, and then we change out a section of the optics on the laser system to get the whole width. Yep. I can tell you that this tool, as I printed it, is not stiff enough to have as much compaction force as we would like to have. So so if you see here, the tool is actually significantly thinner on this side versus that side. It warped a bit as I was printing, and then when I went and machined it, that warp inward resulted in a thinner wall on one side versus the other. So at the bottom of this part with the same compaction force, I go from 200 thou of compaction with the AFP bin to 60 thou. So my tool is deflected an 1/8 of an inch at the top. If I were to print this again, I would probably double the wall the print so I have a little more material there. The large print that's on the other table in there, I actually printed a stiffening rib inside of it. But it has other downsides because that's where you make that turn, you end up with like an inclusion in the print. This is changing direction there. We are only demonstrating the AFP here because these are all pretty lengthy processes. Doing the print on this tool was about 16 hours, and then the full path to CNC from top to bottom is 7 hours. So. We also have some. Some of the other specimens that are sitting over here, we have some different material widths. So this is a 1/2 inch incision consolidated panel. And we also have examples of 2 different core printed materials on an AFP skin.
thing has a pretty crazy delay.
Oh yeah.
It's like now it's 20 seconds or so.
You connected to the Wi-Fi.
Yeah, I am. Yeah, that was like 20 or 30 seconds ago. Are we doing anything with that stream? Is that actually online, or is it just for those TVs? You know?
I think it's just for the TVs.
Nobody's over there. Maybe a couple.
I saw some people sitting over there. Maybe
Oh, cool.
watching.
Nice. This thing has been calibrated. It's kind of shaky.
All right, everyone. If you have any last-minute questions, go ahead and ask that. But barring that, if everyone could go back over to the stage, Maruna has a last-minute announcement before everyone goes to Topgolf.